Okay guys, I think in this video we'll talk about another important characteristic of stack called as LIFO. Okay, so what do you mean by LIFO or LIFO? It is last in first out. Okay, so stack follows this principle guys, last in first out. Okay, so what do you mean by this phrase last in first out? Which it means that the element which you have pushed last, the element which you have pushed at last, okay, pushed last will be the first element which will be popped. Okay, so the element which you push last will be the first element which will be popped. Okay, let's take an example. Okay, so let's say, okay, first I am pushing say 10. Okay, so I am pushing 10, then I'll push 20, so I'll push 20, then I'll push 30. Okay, so I'll push 30, and don't forget that now top points to 30. Okay, top variable. Okay, now understand that I am pushing 10, 20, 30, right? So what is the last element that I have pushed? That is 30. Okay, 30 is the last element that I have pushed because my top also points to 30. So that is the top element or the last element that I have pushed. Okay, so now I'll say pop an element from the stack. I told you that you can only push and pop only from this side, you can't do from this side. Okay, so if I call pop function, if I call pop now, what will be popped? 30 will be popped first. Okay, but I have inserted 30 at last. I have first inserted 10 only. Okay, so this is called as LIFO guys, which means that the last element which is inserted, in this case it's 30, that's the last element which is inserted, will be the first element to go out whenever you call pop, because you can't delete an element from this this side guys. This side is shielded. Okay, so if I say I'm deleting wait a minute, if I say I'm deleting 10, it's wrong. Okay, so you can always delete only the top element. Okay, after that now top will point to this element. After that, if you call pop once more, then you can delete 20. Okay, so this is possible actually. Fine. Okay, super. So understand LIFO structure, the last element will be the first to delete. Okay, based on this, let's have some applications on stack guys. Okay, so the applications would be your undo function in your browsers or Word. Okay, Microsoft Office Word. Okay, so in those softwares you have an super functionality called as undo. What will you do in undo? In undo functionality, you will be having if you do something, then it will be undo. Okay, so, undone. Okay, it will be undone. If you click undo, or if you go for undo, and particular activity will be undone. For example, okay, I'm using that activity here. Let me say, okay, so let me write 1 2 3 4 5. Okay, so I've written 5 numbers here guys. I've written 5 numbers here. Okay, let me click the undo button here. I have a undo button in the screen itself. Let me click that. I'll check what happens. So first, if I click undo button, okay, I think I have to draw that in a single stroke to make you understand. So let me say A, B, a single stroke guys, C and D. Okay, so now if I click undo button, D will be gone. If I click undo button again, C will be gone. If I click undo button again, B will be gone. But if I click undo button again, A will also be gone, which means that I have written only in this fashion guys. A first, B next, C, then D only. But if I the moment I press undo button, the last element which I have inserted is getting deleted. Okay, so the last activity done will be the first to go out, right? So the last activity done will be the first to go out, and this principle is called as LIFO guys. It has a lot of applications, and so stack uses this principle. Understand? I hope I have made it clear. So if I have written something, the last activity which is my D, which will go out when I press undo, then C, then B, then A. Okay, so this is the idea of having LIFO in stacks. Okay guys, so in our next lectures we'll implement some algorithms in stacks. Okay, thanks a lot.